Welcome to this video. I am Has Physics and today we are going to be going over Hooke's law. So first of all, what is Hooke's law? Hooke's law states that the extension of the object is directly proportional to the force applied to it in constant environmental conditions. This can be seen through the graph on the right of the screen, as it is a straight line going through the origin. It can be described using the formula F equals kx, where F equals force, k equals the spring constant, also known as the stiffness of the spring, and x equals the extension of the spring. So, now we're going to be going on to the GCSE example exam style question, where it states, calculate the spring constant k of the spring using the equation F equals k multiplied by x. So it says a weight of 4 newtons is used to extend the spring. The extension of the spring is 0.06 meters. So we know what the force is, which is 4 newtons, and we know what the extension is, which is 0.06 meters. So we just need to rearrange it so we can get k as the subject, so we just divide x on both sides. So we're going to be left with F over x equals k, and so all we need to do is just 4 over 0.06, and that'll give us 66.67 newtons per meter. Now, state what measurements should be made to determine the extension of the spring produced by the weight of 4 newtons. So what we need to do is first measure the spring without any weight acting on it, and then we need to also measure it when the weight is acting on it as well. So what we need to do is measure the initial extension length of the spring without the weight, and then after we need to also measure the final length of the spring with the weight, and that's it. So now we are going to be going on to the A-level example exam style question, where it states, calculate the extension of each spring. So we can see that two identical force meters of this type support a mass of 0.4 kilograms. So we can see that these two force meters are holding up this weight. So first of all, we want to find out what this weight is. So we do W equals mg, so it's 0.4 multiplied by 9.81, and that will equal to 3.924 newtons. And so we know that as the rock isn't going down, we know that the upwards force overall will be 3.924, and as there's two force meters, we need to divide it by 2. In other words, we can say that there is let's label as F, which is the force coming from each individual spring. So 2 multiplied by F, and as it is coming from an angle, we can see 60 over here overall, but from the vertical to where the force meters are, we can see it will be 30 on each side. So it will be cos 30, because we want to find out what this force is, and we know what this force is. So we just do SOHCAHTOA, and we can see that this is the adjacent and this is the hypotenuse, and it will give us cos. And that will equal to 3.924, which is the weight of the rock. So we just need to rearrange it to get F. So we do 3.924 divided by 2 cos 30. Divide both sides by 2 cos 30. And when we do that, we get 2.27 newtons. And as it's asking us for the extension, we need to use the formula F equals kx. and we need to rearrange for x, so we just divide both sides by k. So it will be f over k equals x, and k is given to us in the question, which is 45.45. So we do 2.27 over 45.45. That will give us 0.05 meters. And don't forget the units, as it's not given in the question. So thank you for watching this video. I hope you have learned something from this video, and it would be really appreciated if you could share this video and subscribe. Have a fantastic day.